So in lecture recently, I talked about energy and energies in general. Energies can be tracked. It's got to be conserved. And one broad type of energy that goes quite nicely, can be conserved and converted from one to another is potential energy and kinetic energy. So potential energy is stored energy, or the energy associated with position, and kinetic energy is energy associated with motion. So if we kind of look at this ball, we've thrown this ball up, and let's kind of look at where the ball is kind of hit its maximum height. Okay, I'll go maximum H, and we'll kind of call this H. Okay, and maximum height means that what? It's not going up anymore. Okay, so with regard to kind of going up and down, we say that its velocity up here, velocity is 0. Okay, if its velocity or its movement is equal to 0, then its motion and energy associated with motion in that direction is also 0. So the kinetic energy is 0. Then we can also, though, say with regard to its potential energy, the energy that it potentially could have is if we let gravity take hold and let it drop. Because if its height is also the maximum, we would say its potential energy is equal to its maximum amount up there. Okay, it's not moving, it's just kind of hovering. It's kind of an interesting moment in time, isn't it, with regard to kind of going up and down. So at that point, we basically have all potential energy, no kinetic energy. Then what's going to happen is it's going to go ahead and fall back down. And it's going to fall, going faster and faster and faster according to that 10 meters per second. It's going to get faster every second it falls. So actually then its maximum speed is going to be down here, isn't it? Okay, here it's going to have its V in this direction is equal to max. Okay, and so if its velocity or motion is the max, okay, its kinetic energy is also maxed out. Then if we look at what potential energy it has as it's hit the smack dab down to the floor or whatever, can you see where height is 0? Okay, so actually its potential energy is 0. Okay, so kind of as we've drawn it up here, we have what? A maximum potential energy, 0 kinetic energy, and down here we have maximum kinetic energy and 0 potential energy. So along the way, it basically has kind of halfway as it's fallen, we have kind of half potential energy remaining, half kinetic energy has built up. So that's how one can be kind of converted into the other. But a little closer to home, if we can you kind of see this kind of blue-looking cloud? Okay, this kind of reminds me later on, soon in a unit to come, we're going to talk about the formation of our solar system, which is our sun and the planets and kind of the crumbly things that fall into categories, the asteroids and comets. So actually, it was all kind of made out of the same stuff. Isn't that neat? The sun and the planets, the rocky planets, the Jovian planets, all kind of made out of the same blue stuff, okay, called a solar nebula. That's the material there. But if we go ahead and give this a little bit of spin, we're kind of creating this situation similar to what made our solar system, because we know there had to be spin. A few things. First off is that if it has a little bit of spin, okay, in a minute I'm going to show you the next slide where it shows it much smaller. Okay, and it's like the ice skater who brought her arms in. And if that momentum, angular momentum, needs to be conserved, we're going to see going a lot faster when it gets smaller like that, right? And actually, that speed with which it spins is kind of how it kind of flattens out into the plane of the ecliptic. But the other thing I want to talk about with regard to converting potential energy into kinetic energy is as it's out here, it has a lot of potential energy. It's kind of like that ball at the top of its height. It has a lot of potential energy. So as it becomes smaller, and doesn't this kind of look like the plane of the ecliptic? Okay, a couple things is that with regard to potential energy, it has less potential energy. Energy has to be conserved. Where does it go? It goes to kinetic energy associated with that little frisbee of material that can ultimately become a star system. So we see other stars doing that. I just think that is so exciting. So momentum needs to be conserved. And kinetic and potential energy can be converted to kinetic energy and vice versa. The one last thing I want to kind of touch on, remember I said that all energy needs to be conserved. All energy can be tracked. Energy can be changed between different forms. It can be changed from potential to kinetic and kinetic to potential, but it needs to be conserved. Well, according to Einstein's equation, E is equal to mc squared. Actually, energy and matter can be converted back and forth. And we're going to get into this later, but actually early on in our universe, there was no matter. I mean, very, very, very early on in our universe. And a large amount of it was all energy. And a large amount of energy was converted to matter, okay, to create us. Isn't that exciting? But kind of looking at it another way, you see this mushroom cloud representing a nuclear explosion. And so in nuclear chemistry, matter, a little bit of matter is converted to a lot of energy in nuclear reactions. This looks like an uncontrolled nuclear reaction, especially if you're the person getting bombed. But more probably a pleasant way to think of it is our nuclear power plants. Most of them work on the basis of nuclear fusion. Okay, nuclear fission, which basically means splitting an atom. So the way nuclear fission works is you take a heavy atom like uranium, a special isotope of uranium, and that uranium atom can split into two pieces. So if you weigh the uranium atom before it splits and the pieces after it splits, you're going to see that you've lost a little bit of mass. And it's that mass that actually is converted to energy that's released during this process. Okay, so that's nuclear fission. Nuclear fusion actually happens in the course of suns. What our sun is doing is fusing, put loosely, what our sun is doing is fusing two hydrogen atoms to make a helium atom. Again, if you weigh the two hydrogen atoms and the helium atom that's formed, you're going to see that you've lost a little bit of mass, and that mass has been converted to energy. All stars do it. Okay, and they can fuse different elements, heavier elements than hydrogen, but that's what our sun is doing. So it is possible that energy can be converted to mass, and mass can be converted to energy.